come all the way from sunny California to talk to you about what we're doing in Verizon OnCue. Probably haven't heard of us. You may have heard of Verizon. It's one of the largest companies in the world. It's a Fortune 20 company. OnCue is a recent acquisition by Verizon from Intel, where we were running under a company name called Intel Media. So earlier in the year we were acquired by Verizon, and now we live at Verizon. So we're using functional programming for a range of different things, but we have a very large greenfield project, and what we're working on is Intel Media was founded with the goal of basically redefining the way that media consumption works. Media to TV delivery was done. I appreciate we're in Europe, so it's kind of difficult. The market for TV and media is different in the US, so it's somewhat kind of well, I probably shouldn't comment on that, but nonetheless, we have a large greenfield system, and we're building everything from the silicon to the services, so, hardware, product, services, firmware, absolutely everything. The entire stack. Our goal was to own the entire stack end to end, so that we could build something that was kind of very different. Most of the time, when you're OEMing stuff from other vendors, you don't have that flexibility. So that was kind of our goal as when we were founded, and that continues to be our goal today. Although I guess when I talk about greenfield, it's not really. It's when most people infer it to be a greenfield, like they really are they're kind of talking about like one particular project in one particular like part of a company, and it's just this sort of smaller thing within a larger entity, and eventually they kind of have to sort of integrate with, I don't know, mainframe or SOAP service or some technology which you really don't have to work with. But we just really don't have any of that. The entire thing is greenfield. That's definitely come with its own challenges, but nonetheless, from day one, we decided to use Scala for our services. And we're going to be talking about what we're doing on the service side. Our service platform is pretty large. I'm not going to be talking about product or brand or anything else like that. You're probably not that interested anyway. Really more interested in functional programming, but yeah. So from day one, we decided to use Scala. We are, I guess from day one, the leaders of our organization decided that that they wanted to take. They already sold on functional programming, so I guess somewhat in contradiction to Joe's previous talk. Sometimes the management can get sold on a particular technology, and sort of there's a premise that this is actually much better than what we're already using. So they were kind of already sold on it, and so from the very outset, we knew we wanted to do everything in as functional style as we could, and that's going to give us an interesting set of challenges, and we've definitely broken a fair number of eggs as we've tried to do that. It occurred to me actually just while I was writing this talk, there is a really good reason that many companies don't do greenfield projects, primarily because you make an awful lot of mistakes and it's very, very expensive. Nonetheless, we've learned an awful lot, and I guess one of the things I want to talk to you about today is some of the things we've learned and some of the sort of interesting things we've discovered, or at least I perceive them to be interesting. So to give you some context, our team has absolutely exploded. In the first 12 months, we grew by an order of magnitude. So we're growing very, very quickly. Most companies, they might grow 2 or 3 people maybe a month or maybe a year. We're growing sort of 3 or 4 people a week. So it's like growing very, very quickly, which is kind of amazing in and of itself. Simply that you can hire that many people, but nonetheless, we're growing very, very quickly. I mean, we literally have such a broad range of people. I mean, everything from the folks who are working on, sort of firmware and below. In fact, actually, one of the gentlemen who was working on that, one time we had a conversation, and he was asking about, JSON, JSON, and he wanted to understand what it was because everyone was talking about it, and then I explained what it was, serialization technology, etc. And then he just gives me a very blank stare and then says, "Oh, user level code." Because it's just from his perspective, it's just it's just users, whatever. But so that's the kind of breadth of people we have on the team, and it's growing very, very quickly, and it still is. We've been at this for about 2.5 years now, by the way. So yeah, we're growing fairly quickly. So sort of on this sort of vein of growing very quickly, we kind of realized early on that we can't hire the number of functional programmers we need. That they don't exist. I mean, can you imagine trying to hire 3 or 4 functional programmers a week? It's not possible. Well, maybe it is somewhere, but I don't know. It's like a utopia. They probably have unicorns and stuff there, but it's not possible. So what we did realize was that you know, we have to make make use of the available engineering talent, and a lot of very smart people around. It's just that they just don't have the particular skills today that we need. So, you know, but what they do have is a high attitude. So we realized that, you know, so every engineer that we would hire was unique, but not because of what they knew, because of what they don't know. And this kind of gives us a very interesting problem. And these people they have like a diverse set of backgrounds. Some people are doing C++, some people are doing, you know, Ruby, some people are doing, you know, all manner of things actually. And some people were doing functional programming. Several people who have a heavy background in Haskell, Scala, you know, so on and so on. And ML and Lisp for some of the older people. And, you know, so it's a very, very mixed bag. And for some reason, you know, well, somehow we have to try and kind of get some kind of coordination on what people are doing and, you know, teach everyone this new language and this new thing. So we kind of realized that, actually, so these are they're not data to sort these guys, it's just kind of indications. So it's easy to explain with some kind of diagram. I guess I'm kind of a fairly visual learner, so this is kind of easier for me. But nonetheless, we noticed that there's a kind of two trends, and there are two types of people that we could typically hire in the marketplace. So type A, if you like, was kind of the people who've been doing one language for a set period of time, and, you know, so they've just been doing it over time, and then sort of their perception of how easy or not it was like to become a functional programmer. You know, you might have someone who's kind of been doing it for some time, maybe they're out of college or something like that, but they have kind of sort of less soft debt to essentially get rid of. And in many respects, it's kind of like, from a learning functional programming perspective, they're sort of, it's like, and you're starting from like a negative position, and they have to kind of erase what they already know because they think in this very imperative fashion, and sort of have to unlearn. I kind of dislike the word unlearning because but there's not really anything else I can use in its place, simply because it kind of implies that it sort of happens in one step, that they unlearn something, but it's really not like that. It's something that they kind of they fight against for quite some time, to be honest. And then sort of on the upper part is, you know, for people who've been doing, let's say, for example, Java, if they've been doing Java their entire career, the amount of sort of unlearning they have to do is actually very considerable. And it's not that these people are, you know, not smart or anything like that. It's actually quite the opposite. They're very experienced, and they bring a lot of depth to what they, you know, to say, in our case, it's the JVM, we're using Scala. You know, so they understand all the operational intricacies of, you know, the GC and so on and so on, and all those fun things that you get on the JVM. So it's not, they're not smart or anything like that, but it's just the level of unlearning is like a sort of degree of inertia that's very significant. So I asked one of my colleagues about this. He himself is sort of a long-time Java guy, very experienced, and he described it as a constant struggle against his own instincts. And this, I really like this because this is kind of a very, you know, that's pretty much how it is, and there really isn't any way that we can kind of, well, we came up with some strategies to try and reduce it, but it's different for everyone. And this is actually really kind of, from a business perspective, kind of problematic because it means that everyone is learning at a very different rate. So that if that's like the type A people that you hire that have been doing one particular language for a period, can I take questions at the end? I'll come back to you. So sort of the type B people are the kind of people who've been flitting around lots of different paradigms of programming. So they've been doing imperative programming, they've been doing declarative programming, concatenative programming, you know, so on. And these people, like PL nerds essentially, probably in that category. But it's learning FP is just like it's a lot more fixed for those people. So they have just a very they have a good ability to pick up functional programming, you know, in a fairly quick amount of time, and then there's a small bump, and then they kind of get to the very high, you know, the higher level stuff. And so for the longest time, we kind of weren't too sure, you know, who should we really be hiring? Should we just be hiring these, like, you know, PR nerds that, like, really, you know, well, they're kind of a small bucket as well, and, you know, so what do? And we actually realized that in order to make a strong team, you actually do definitely need both, especially in a corporation. So anyone who's ever worked in a large company will definitely understand that, you know, there has to be, it's like a continual degree of evangelism. For FP at least, this has sort of this ongoing evangelism, sort of internal marketing about, you know, why we actually do need to be doing this and why this is important. And that's really super important because without that, it's very easy for an organization and for the hiring managers to sort of immediately do a U-turn and be like, hey guys, we can't find any functional programmers, how about we just get some, you know, as Joe said, a 10-pack of Java programmers. And, you know, this is actually a real problem because large organizations do have a tendency to want to do this. So yeah, that's why I say, you know, you really need both. You need people who bring the experience over time, and you also need the people who essentially keep those other people buzzed about doing functional programming. So the other thing we learned was that essentially any kind of it's just like any distributed system. If you have a centralized anything, it's going to fail, and it's going to be a single point of failure. And the same is true of education. We actually started out and maybe somewhat naively thought, we will train people, and it works up until a point, but the problem is that for many people in the field, myself included actually, are not great classroom learners. We don't learn very well in the classroom environment. It's better to, personally I don't learn like that. So, we kind of realized that actually many people don't learn like that, and it works for some people but not for others, but again, we kind of end up with this inconsistent output. So instead what we did is we tried to foster a sort of culture where, it's okay to learn and it's okay to not know. Because in many large companies, there's kind of a sort of inertia with people admitting you don't know something is kind of like people don't like to do that. They feel, people feel vulnerable when they learn. So, we realized that fairly early on. And so what we tried to do instead was to basically provide space to learn and say, it's okay to make mistakes. It is okay to fail. We tried to encourage them to experiment. Now, that's kind of been, I guess that's kind of been one of the most difficult things from the sort of business perspective, just because you're sent for the business to be paying them to learn, but sort of they perceive that as like not shipping features. So you kind of end up having to have this like place where you can, I guess, kind of still ship features, accrue a degree of technical debt, but also give people space to learn. So I guess trying to segue on to my next topic. I was walking in the Yosemite Valley a few weekends ago. We were in the sequoia groves, and they're like these huge trees, and they have, they only really grow leaves at the top, and they're absolutely ginormous if you've never seen them. They're the largest trees in the world. And so, in many respects, our organization is very like this. The roots of the sequoia, they don't grow, there's no like taproot, they don't grow long, they just grow very shallow and very kind of matted and very kind of strong, and they support this massive structure. And so without this, so these are kind of the libraries of the organization, the thing that everyone uses, that everything else is built upon. And so I guess if you follow my tenuous metaphor, the leaves are essentially the services of our organization. They're just the edge of everything else. And they flourish later after you've got like an infrastructure and libraries or anything else. And so one of the things that we realized early on was that actually it's very counterintuitive, but libraries can be very dangerous. And we were growing so quickly that it just, when you have people, if you think about technical debt in your organization, like I say, you want to try and give people space to learn, but what you also want to do is make sure that you accrue technical debt in the right place. So when people were learning, what we first did is we encouraged everyone to basically, yep, this code's super reusable, like, you made these functions, you can put that into a library, and that actually kind of hurt us quite a lot initially, because what we were doing is, unwittingly, we realized that accruing technical debt in libraries is actually very difficult to remove. It's actually very hard to factor out. It takes much longer, like inordinately longer than it does to refactor a service. I really don't like the term microservice because it's so fashionable, but most of our services are very small, so either replacing or rewriting a service is a much smaller deal than it is to replace a library that's sharded through hundreds and hundreds of services. So this is kind of like takes an inordinate amount of time to do that. So in that frame, kind of, these libraries can be dangerous if they're like in the hands of someone who's only just picked up functional programming, because they might be mixing so Scala's impure, yes, we know this. Like, it has some problems. It's not Haskell, in that frame, like that can actually be really that specific thing. The fact that Scala is impure for newbies writing libraries that are then going to be consumed by a larger engineering team, that actually became a problem. So we stopped doing that essentially, and we pulled in all the libraries into one specific team who did have a lot of functional programming experience, and now basically that's raised our level of service for the rest of the organization. Now there's a clear line of maintenance, so on and so forth. We had a range of ancillary benefits of doing that. And actually, people are just generally happier because like these libraries, it becomes the thing that you have to maintain over time, so they actually have to be designed fairly well in the first place. So one thing that we did from a learning perspective is we actually decided that we would write libraries in a functional style, but we would provide an Perrett API, or in some cases we would provide a dual API. So people will either use a function interface, or if they weren't comfortable with that, an application was not yet designed to do in a functional manner, that we would give them an imperative API. This is kind of an interesting thing because there was a lot of debate internally about whether or not we should even be doing this. Like, should we force people to, so for example, like we have two types of application. We have applications that are built as free monads, and the whole thing's free, and that actually works really nicely. And that's it's super easy to use these functional library APIs in that kind of setting. And then you have kind of, I don't know, let's say something that's not really that functional, like play, that because of the way that it uses state and other things, like using these sort of functional libraries can just be a complete nightmare. So we ended up adding these imperative APIs solely so that, this is, I guess, essentially an enabler to reduce the learning curve so that people weren't forced to do things, and critically that they can still ship their features. Because, like it or not, the business still wants its stuff delivered. So, if we've got the opportunity to make it a little bit easier for people, and say, still continue to educate on the one hand, but don't block them from doing their work. So, I'll just show two quick slides from two libraries we have, and then I'll talk a little bit about some of the other libraries because they're kind of awesome. So, like I say, we do two things. One is that we kind of try and provide libraries that are easy to read, and they almost might look imperative, but they're not. So we have we ported data.configurator from Haskell and basically made it more awesome. And we have a configuration library that's based on that. I just found out that at the front here was the guy who wrote the ActualSec parsers that we actually use for that, so that was kind of awesome. But yeah, so we have that. That's a relatively functional API, and it's easy for people to use because it kind of looks imperative. But likewise, not also compatible with some other applications if they're written in a very imperative fashion, like it's essentially Java with that semicolons. And then we have another library. So we have an imperative API on top of our monitoring library, and our monitoring library, by the way, is entirely based on Scala-Z Stream. I'll talk a little bit about that more in a minute. So we provide an imperative API because that's kind of very easy for people. It's a sort of a side-effecty API on top of this very functional core. Overall, so this I've got several slides. So I'm just going to try and flood through a few more because I'm running a bit short on time. Just generally, writing from scratch has been a huge win for us. We have a range of internal libraries for monitoring and configuration. We also ported the FGL from Haskell, logging with a functional RPC systems based on several academic papers. It's just been a huge win for us because we just really have it's for maintenance and everything, it's much better. So I appreciate most companies can't do that, but for us it's been a huge win. We've essentially tried to minimize our external dependencies. We are wildly using Scala-Z Stream, Scodex, Shapeless. This is kind of all over the stack in our libraries. So, but I put a note there. Yeah, working on the JVM does kind of make this problematic. Java is just a bit of a nightmare. But anyway, so coming to some points because I'm kind of running short on time. So was it worth it? I think 100% yes. Now the reason is that we've taken a lot of. I guess essentially we took a huge hit and quite a large gamble, essentially choosing to do everything in Scala from day one. But I think overall, we'd do it again. It's been a huge win. Now the reason it's been a huge win is because change is so easy. We just don't even notice it on a daily basis. For example, in the library I was just talking about, the configuration library, we actually decided that we wanted to add zookeeper support so we could dynamically change configuration values. That whole thing, the whole zookeeper support, is like 58 lines of code. So it's like it's just change is so easy. We just don't even notice it. So like I can't even imagine doing that in Java and trying to extend something. I mean, obviously we don't have type classes, but yeah, I can't even imagine doing that in Java with it being 58 lines of code. It'd probably be like 5,800 lines of code. Final thing. Our teams are actually pretty happy, surprisingly. So this is kind of actually I think something that wasn't talked about I guess in Joe's talk, but engineers like doing new stuff, and they're actually, if they feel like they're having a good time and they're learning, they're actually pretty happy, and happy teams are productive teams. So this actually has been kind of, I know it's a really soft thing and very intangible, but that's actually been a very large win for us. That our teams are pretty happy, morale is pretty high, and people like what they're working on. So last 30 seconds. We're hiring absolutely every level of the stack, from firmware to services, and everything in between, silicon and whatnot, everything. So thank you very much for listening. Sorry about the rush. If you've got any questions, I know there was one at the back. I'll happily take them.
About 3 minutes for questions.
Tom Hoffman from Airline Solutions. When is the point of no return? When have you been spending too much time in an imperative language so it becomes too hard?
That's a really good question. I'm not sure there is a point of no return. I think it's just a case of how much time you're willing to invest in yourself. So, for instance, one thing we've seen is there's no kind of concrete thing. If you've been doing Java for 10 years, like some people who have are just very adept at learning. For example, we have one gentleman who he'd been doing Java. He'd been working on the Oracle JDK, and then afterwards he learned Java. He learned Scala pretty quickly, actually, in a matter of a couple of months. And he's still learning, of course, but it's sort of like a ramp-up time. I think it's like the sort of hockey stick, essentially. So I don't think there's. I'd like to think there's never a point of no return, because you can always kind of bring the Java people in from the code. So it's
okay. Then I'll ask in a more politically correct way. How long does it take to retrain a Java programmer? When are you more productive in Scala than you were in Java?
Again, in terms of like a broad rule, I don't think you can actually make a generic rule there, because it's very different. Like I said, every engineer is unique. We realized that after about, I don't know, about 6 months. Is that just no two people are the same, but they're unique because of what they don't know. So it's like for everyone it's quite different. You might have one person that it takes like a year for them to really get like sort of Mona, which is the most hilarious thing to try and teach people, by the way. And other people like for example, we had one intern who I spent 2 days. He was mainly using MATLAB, and I spent 2 days with him, and I didn't even teach him the Scala standard library. We just got him using Scala Z, and he was just like, yeah, obviously this is obviously semi-grid, whatever. Like he can like see these abstractions like immediately because he has a very strong math background. So it's very wildly varying.
Hi, I'm Thomas Harper from Knowledge. So you hire people based on what you say, aptitude instead of specific skills, which I think is incredibly reasonable. What do you do when you hire to get a sense that people have this aptitude? What makes you discard a candidate and say, well, not to put it, they're not interested, or they know Java and they're not going to learn functional programming?
So it's kind of interesting, actually. So I know I've got like 30 seconds, so I'll try and compress the answer. Broadly speaking, what we try and do is we find that many people, we advertise the fact that we do functional programming when we're interviewing people, so it's kind of like, this is what we're doing, and then typically speaking, some people will be like, they actually kind of almost filter themselves out in that sense. But for the people who do seem engaged, and then we're trying to figure out whether or not they have like, something that this is something that would be a good fit. We have a couple of different ways of hiring. So one is that we have a set of challenges that we set people to do, like tasks essentially, like build this thing. You can use any technology you want, but just build it. We're trying to figure out whether or not, like, how do they write their code? Do they do, how do they write tests immediately? Do they do this? Do they do that? Like, whether or not they've done it in Python or Java is kind of irrelevant, because we have people who know those languages, so we can always check it. So typically we try and get people to do tasks based on something, a problem domain that we set them. I don't want to talk too much about that.
No, it's okay. Thank you.
Thank you. Again. Next up we have Maxime Renz from Bloomberg.